All right, let's finish up what we did last time. Where we left out last time. We had the same data set. First thing we decided, we determined our class set. Actually, flip on these. Our data was on the first page of your set. That's the data set we're using. Remember how we got the class set, the dimensions of it? The steps we did there? Should I go over that or just look over your notes? Okay, what are the steps? Hold on. To find the class set.
Find the range
First. Range. Range is determined how? So it's largest number minus or plus. Why would it not be plus? Yeah, it defines the average number, not the distance between them. Very good. Because the distance is the difference. And then divide by the number of classes we want. This is the only thing that we have free choice over. And in this last one, we chose what? You sure we chose 8? Yes. So we chose n equals 8. What's that?
But what is n represent?
How many intervals do we want?
Okay.
Or the size? So how many, the class size interval, how big do we want it? 8. So then next step.
On the top of it, 26 minus 27.
What's that?
Huh?
I lost what you said.
You're gonna put 96 minus 27 divided by.
Oh, okay. Yes, so it's the largest number was,
96.
you sure it's 96, 92?
Oh, well, on my paper it says everything.
Because we used this data set.
Why did I even?
There's 92. There's a 91. So largest number is 92.
Oh, yeah.
So it's 92 minus the smallest number was 27 divided by 8. And we did that, it gave us 92 minus 27 is 65 over 8. 65 divided by 8. This is the range. So the range is equal to 8.125. And since we want integers as our range, we rounded up to 9. So what do we do from there? Once we have this size right here, what do we do? Adding what? Actually, no, that was 8 was the first one we did. Then we started another one here. The second one we want to look at, for this one, we wanted 7. Because I'm gonna show you, the first time we did it, we did 8. Then I would say, because the freedom of choice is this one, everybody in here would probably have a different value of n that they'd pick of how many sets they want. So because of that, let's see how much of a change it would be if we change it from 8 to 7. So instead of 8, it's 7. So what we get there? Oh no, we picked 10 because we wanted a lot of them. I have to catch up where we were just last time. So 85 divided by 10 is 6.5, which rounds up to 7. 65 divided by 10 is 6.5.
Oh, thanks.
No, 65. Because the range of the numbers won't change. So the only thing different is it's the bottom. Whether you use 7, 8, 10, whatever, no matter. We use 10 because that's how many classes we have here. So this is the range. When it says range, what is it talking about? Range of what? Of where to where? What numbers from where to where? The way we do it is this way. Since our range is 7, we start with the lowest number and add 7 to it. This is called the lower bound. And this is called the upper bound. Because we want all this, because once we have 27 plus 7 is 34, that means we know where this previous set ends. It starts at 27, goes to 33. 34 plus 7 is 41. That means the previous one stops at 40. So we keep on doing that. We add 7, 1 before there. Add 7, 1 before there. And we keep on going. We have all these. How many of these do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that's because we chose n as 10. We wanted 10 sets. All right. Now, typically what we do here, we change it to, because what if something happened between there, like 33.6 or 33.4? So what do we do? The next step from here is what?
Minus 0.5 plus.
Yes. Now, why is it 0.5? Why is it not 0.05?
But it can be if it was, we did it in the homework.
Yeah. If your data set was like from 31.2 to 38.7. Yeah. Here you subtract 0.05 so that it becomes 31.15. Yeah. So however many decimal places, one extra spot for the 0.5. All right, so that's pretty important. For this one here, we would add 0.05. So it's 38.75. I'm sorry, you can't see that. So the lower one, wherever many decimal places you have, go to one next to it. So if you had 3 decimal places, you have 0.0005. So that's what we'd do next. So we'd go 26.5 to 33.5. 33.5 to 40.5. This one would be 40.5 to 47.5. 47.5 to 54.5. 54.5 to 61.5. So it makes it much easier for you because once you find this value, it just goes over here. We add 82.5. That carries over to 89.5. Okay, so these are our class bounds. So if the answer was 33.5, which one would it go into? The top or the bottom one? Let's say my data set was 33.5. Where would it go? Why?
Not under 30%.
Well, because you have to start at the lowest part. In other words, if the data was 26.5, you had to include it. So that's why the lower bound is included and the upper bound goes up to infinitely close to it, but not included. But you're right. That's the reason why the lower bound's counted, upper bound isn't. So what do you do next with this data? Okay, it would help if you guys do your table because you have your data set also in that sheet I gave you 2 weeks. Complete the rest of this table. What would you do next? Anybody? What would you do next? Well, this is where you look at your data and you figure out where it goes. How do we do that? What do we have to create first? The tally column. All right, so go ahead and do those. You should have the data in front of you, so go ahead and work it out. Don't copy mine. Look at your sheets. Don't copy mine. Do it yourself. Maybe this will help you. And if you have any questions, this is the time to ask. So once you go from the tally to the frequency column, you add them all up. This number here should equal how many data points you have. This is your N. How many data points you have. If it doesn't equal 50, guess what? Something went wrong. Either you misadded or you skipped one during the whole process. So is this one going to look different than our first time we did this? How different? Yes, but I ask you why. I don't take yes, no, it's why would it be different? Or why would it not be different? The range is the same. What's that? No. We did that last time also. But it does have to do with what part of the finding the range. Okay, there's two parts. We have to find the largest number minus the smaller number. That's really how far it is in numbers. But what we did to find the interval sizes, when we took the range and divided by n, that's the interval size. So the first time we did it here, what was our interval size? What was our n? 1, 2, 3, 4, 5, 6, 7, 8. Our interval size was 8. So those are the frequencies. Now, our frequency or sample size, or number of intervals, is 10. This is our frequency now. How do we compare those two? They're different sizes, so we can't really just look at them and compare them. So how would we compare them? You can't subtract because since there's 10 of these, only 8 of the other ones, you'd have 2 of them that don't have anything. So they may be negative or maybe positive, depending on how you do it. So how would you compare two different data set sizes? What's worth 1,000 words? A picture, a graph. So let's look at the graphs of these. What graph would you rather use? Which is the easiest one to use? The histogram is always the easiest one to use. Why? Because it goes in intervals. So the first interval is from 27 to 35. Then from 35 to 44. Then from 44 to 53. From 53 to 62. 62 to 71. 71 to 80. 80 to 89. And 89 to 98. So these are our intervals. What goes on the vertical line? The frequency. One, two. Our largest, well, I would do everything then. 2, 4, 6, 8, 10, 12, 14, 16. The reason being because our largest frequency in our data set was 15 units large. So we look at our first set. From 27 to 35, there's 1. From 27 to 35, there's only 1. From 36 to 44, there are 3. From 45 to 53, there are 9. So the 9's all the way up here. Then from 54 to 62, there are 15. 15's all the way up there. Then from 63 to 71, there are 10. And from 72 to 80, there are 3. From 81 to 89, there are 7. And then from 90 to 91 or 98, there are 2. That doesn't look too good, does it? How do we improve that so it's easier to read for us? How tall is this one? 4, yeah, exactly. Once you see it, you don't even know until you compare it. So one thing we do is on top of these, we put the actual frequencies. Now it gives us a better idea what's going on. No, I'm sorry. I want to sit closer. You want to sit closer? Or I can write smaller. I mean, right. Okay. Okay, so that's that one. That's our first data set. Then we do the same thing with the new data set we have. So with this one, we have to go with these intervals from 27 to 33. We'll start at 27, go to 33. Then 27 goes to 34. Then to 41. Then to 48. Then to 55. 62. 69. 76. 83. 90 to 96. Crap, ran out of space. I can't move it over. So look at my frequencies. The largest frequency is 10. So I could do 1, 2, 3, 4, 5, 6. What's that? So the first frequency of the set is from 27 to 33 is only 1. And we keep on doing the rest of them. 276. 10944.
this first one, I think. Oh, I know we did a second one. Last one time. Okay. This one. No, we need to get one. And you did the first one, it's always the second one.
76. 1276. 1276. 109. 44. 1, 83. So 76 to 82 is 4. What is 62? I messed one up. It's 38 to 48. Okay. I gotta redo these. I can't flip my data over. So there are the two graphs. How distinctly different are they? How would you interpret these if you saw them? Remember, the reason you draw a graph is because you want to convey some information. So what would you get from that information? Which one would you rather see if you were a manager or a boss or an owner? Why? Was what? No. One thing the top one has that the bottom one doesn't, it's more symmetrical. It looks like a bell curve, which we're gonna talk about later on in this course. Because it's more symmetric about the middle. But the middle one kind of looks the same, but it has a couple of bumps and valleys in there. But you see at the very end of this one, and the second one, instead of going down like the other one did, this one goes up, down, up again. So we have 2 peaks. This one we have 3 peaks. So you see the number of intervals that you have drastically affect your outcomes of your graphs, which is one of the ways people lie, cheat, and steal with statistics. I don't like this graph, so I'll change the way it looks. I'll just have more of them. So, okay. Where's my... What we're going to look at now, because when we created this chart, we had the class, this is the set, this class bounds. Then we had the tally. Then we had the frequency. The next column, this is what is called a frequency distribution. What do you think a frequency distribution means? Okay, everybody here, I don't want to have any cell phones out. I don't want any earbuds in your ears. I don't want anything that effect. So if you have earbuds in your ears, take them out. And never again. Because there should be no reason you have earbuds in here. So what is the purpose of a frequency distribution? What's that? Into, you're getting close. Not really groups. Because you want to break it down into frequencies. You want to see how it behaves. And we do break it down into groups. So we look at how each group, which class, how they interact. Is there one that's more popular than the other? So in this last one we just had here, one application of this could be if you're a manager of a store getting near Christmas. Look at last year's Christmas sales. Well, we're pretty sure that between 53 and 62 and 55 and 61. So that's a pretty good estimation that those are going to be our biggest sellers, whatever that interval is. And then the next one next to it, all the way up to 71. So this is how you would interpret these things. You look at, if you're in sales, you look at that. If you're looking at losses, be very careful because more people are stealing these things than anything else. So what would you do if you were a manager? If you see those are the losses, well, just have one on the item, on the one display on the floor that doesn't have anything in the box. It's empty. And then if they want something, and you go get it in the back. Which is the way I think they always should do it, because too many people just come and steal things and we have to pay for it. So that's a purpose of a frequency distribution. All right. Now, the next step in a frequency distribution is we want to talk about what's called the relative frequency. What do you think relative frequency stands for, represents? Relative to what? What's that? Not to itself. Relative to something else, something bigger. It's relative to all of the, how many items you have. Because, for example, we saw our data set. Let's use the first one since it's smaller. So in the first one, we had 27 to 35. We had 136 to 44. We had 3 45 to 53. We had 9 54 to 62. We had 15 63 to 71. We had 10 72 to 80. We had 3 81 to 89. We had 7 90 to 98. We had 2. Okay, we have the frequency. That's perfectly fine and dandy. But it really tells us nothing about how it relates to everything else. The relative frequency, oops, I put that one. Is the frequency divided by how many elements you have times 100. Well, let's hold off on the 100. We'll talk about what that does in a minute. So if you have this as a relative frequency, what does n represent? How do you find n? Yeah, add up all your frequencies. That equals your value for n. In this case, n equals 50. So the relative frequency, let me get my calculator out. Since asking calculators from the audience will take forever, because too busy thinking. The first one, what is the relative frequency of the first set? Again, you can't do it in your head. It's a formula. There's your formula. This is the relative frequency formula. Forget the times 100 right now. So how do you find the relative frequency of the first set? What does this tell you? And n is what? Which is what in this case? So 1 over 50. So for our first one, our relative frequency is 0.02. The next one, 3 over 50. 0.06. Complete the rest of the chart. Yes, yes, yes. See, that's the thing about it is she, if this was a ideal class, that question should never been brought up. But too many students bring out their cell phones, listen to earbuds and crap like that. I can't trust you. It makes two of us. I never in my entire life ever used one in class. I don't like them. Yep. What should that equal if you add it all up? You sure? Try it. Yeah, that's another, that's your checks and balance number two. It should equal 1.00. If it doesn't, then one of a couple of things can happen. One, this is important. Never round until you get to the final answer. Never round until you get to the final answer. If you do, that's going to give you a rounding error, which will make this no longer 1.00. It'll make it something else, either bigger or smaller. Okay, looking at those numbers, they don't tell us too much. Percent. How do you find percent? What's the formula for percent? No. Close though. Percent is part over total times 100. Because you're right. The percent by definition, the word itself means 1 over 100. But we're going from decimal 2%. So instead of dividing, we're multiplying by 100. So basically, we're just taking the relative, this is the relative frequency. It's the part over total. That's the relative frequency. And if you times 100, you get the percent. So it's the relative frequency times 100. So that means the first one is going to be what? 0.02 times 100 is 2%. You just move the decimal 2 to the right. So the next one is 6%, 18%, 30%. Now, do those numbers represent give you a better feeling of what's going on with the data than decimals? Yes, because we're used to seeing percent. So out of all these, which one shows us the most activity? Yeah, the 30% is the biggest in percent. That happens at 54 to 62. So whatever is happening in that range or that interval is the most active. That's where the most change occurs. If we add up all those, what do we get? We hopefully get 100%. That's your checks and balance number three. How do we find the average of this type of data? We have intervals. We have frequencies. This we don't need for the mean, median, mode. Well, out of the mean, median, mode, which are also called what? The measures of what? Central tendency, yes. Central distribution that goes with variance. It's called measures of central tendency. What can this stuff tell us automatically out of those three? Can it tell us anything? Mean, median, mode? And so it tells us what? Just by looking at this information, out of those three, what can you tell me? The mode is right. But remember, what we used to call mode was a number. Whenever you have intervals, this is called the modal class. You look for which class has the highest frequency of occurrences. or in this case, you go to the highest frequency. So that's a modal class. And again, it's as accurate as that. Do we know what number is most active inside there? No, we just know it happens in this interval. So how would we find the average of this data? How do we find, remember, when we did it in the past time, we had the data and we had the frequencies. So we had 1, 2, 3, 4. There were 5 of these, 2 of these, 6 of these, and 2 of these. How do we find the average for those? See, what I'm saying is, having your cell phones out, you guys are tempted to go texting and searching. Stop. If I see it again, no more. No more. I mean, if you can't trust yourself, put it away. So how would we find the average of this small data set here? Think about it. Wait. Like that? Sure. But think about it. If we looked at our data, because we know how to find the average, add up all the data set and divide by how many you have. First off, how do we know how many we have? Yeah, we do. Nope.
And total is 8.
Nope.
Okay, so the X is like the actual number.
This is the data. This is the frequency of those. As I said, X is the data, always. So what's our N to begin with in this data set? What's our N? Because remember, what we did to find the mean was add up all the data and divide by N. That's how we did it in chapter 1. How do we do it now? What's our N in this example? We just talked about it a second ago. Actually, it's still on the page on the screen. It's what? How'd you get that? Right. Add up all your frequencies, you get N. So the summation of all your frequencies, 5 plus 2 is 7, 6 plus 2 is 8, 7 plus 8 is 15. That is what our N equals. Now, when we have frequency distributions, so when we have larger pieces of data, think about what is multiplication? Turbo addition, right? So what we have here, if we have one, this is our data set. We have 1 5. We have 2 2s, so it's 2 2s. Then we have 6 3s. Then we have 2 4s. Oh, we have 5 1s. I'm sorry. This is 1. This is 1, 2, 3, 4, 5. We're supposed to have 15 pieces of data. So you see, instead of having 1 plus 1 plus 1 plus 1, that's addition, I can go 1 times 5. So here, if I multiply these two together, 1 plus 1 plus 1 plus 1 plus 1 is the same as 1 to 5, so that equals 5. 2 plus 2 is the same thing as what? 2 occurs 2 times, that equals 4. 3 plus 3 plus 3 plus 3 plus 3 is 3 happening 6 times, so that equals 18. And then 4 plus 4 is 8. So that's 4 times 2 is 8. Whenever you have frequencies, you no longer count each one of these separately. You have to multiply how many of the elements you have times how many times they occur. So to find, when we have frequency distributions, if we add up all of these, that's the same as adding up all this whole big list here. So the summation of x times f over 15. Whenever you have frequency distributions, the mean is your x values times how many times they occur divided by n. That's your average. So add up all these, how do we get? 18 plus 8 is 26. 5 plus 4 is 9. So it's 35 over 15. Five goes in 35 7 times. 5 goes in there 3 times. So it's 3 2/3. 3.666666666. So that's the average. So if you have a frequency distribution, then the mean is the summation of your x times your f over n. And remember, what is n? N is the summation of all your frequencies. What does that, how do you read this? X tilde. And what does it represent? The median. Now we have a problem. How do we find the median with a frequency distribution? To find x tilde, we need to know the cumulative frequency of the data. What does cumulative mean? Overall. Very good. Yeah, the cumulative final exam is over the entire semester. So the cumulative frequency. So look at our data set here. Another name for cumulative frequency is called the running total. So the cumulative frequency, begin with the first set. That one just comes over, so it's 5. What we're looking at is everything from 1 and below. How many of them are there? There are 5. How many of them are there from 2 below? So we take this number add it to this, and we get that. We take this number, add it to the next frequency, we get 13. Take this frequency and that, and we get 15. This is your N. It's the fourth way we can check our answers. Make sure our system's correct. Now, what do these tell us? It tells us that from this class down, there are 7 pieces of data. From this class down, there are 13 pieces of data. And then from this one down, all 15 pieces of data exist. That's what the cumulative tells us all along. Why do we need to know that? How do we find the median? Remember first step? Take n divided by 2. Because we're looking, the median is a location, is a number at a location. So we have 15 divided by 2 is what? What's that? If it's 14, 14 divided by 2 is 7, so it's a little bit 7. It's 7.5. Okay, if it's a decimal, what do we do? Round it up to the next digit. Remember, what does this number represent? This is a location of the median. Okay, so where would the 8th number be? Is it in the first set? It has only 5? Is in the next one? Next one stops at 7, so it goes here. So this one starts off at 8 and goes to 13. That's the number of data points. So the 8th number is 3. That's the median. Okay, what if we had an even number of data points? One, two, three, 5, 3, 6, 4. So in our cumulative frequency, what goes in the first row? Right. It's 5. Because what the cumulative frequency is, in this row down, how many pieces of data are there? There are only 5. How about the next one? 5 plus 3 is 8. In the next one, we have 5 plus 6 is 14. And the next one, we have 14 plus 4 is 18. So again, what does this number tell us? It tells us from this data set down, there are 14 elements of our data set. That's what it tells us. So let's find the median. First step, take n divided by 2. What is our n? The last number in our cumulative frequency is our n, because it's the same number as all the frequencies. So we have 18 divided by 2 is 9. So what do we do? If it's an integer, what do? We go to this location first. and then go to the next location, the 10th location, get those two numbers and add them together, divide by 2. So what number is the 9th number in our data set? Yeah, so 9 is bigger than 5, 9 is bigger than 8, so it has to be in this set. So it's a 3. The 9th number is a 3. What's the 10th number? 10 is bigger than 5, 10 is bigger than 8, but it's less than 14, so it's also in this set. So the median is 3. And the mode would be what? Yeah, it'd be 3 because there's most 3s. Is it a modal class or is it mode? 4 is only 2. The cumulative? No. For the mode is only the frequency. Would it be a modal class or would it be a mode number? Is that a question or an answer? Are these classes or are these numbers? They're numbers. There's classes would be if they're intervals. It will be a modal class if there's an interval. Since this is just a solid number, it's the mode. So far, so good. So that's if we have regular data and frequencies. Now things change. Six to 10. So what if I wanted to know the mean of this set? So when you have a frequency distribution with intervals, so if you have a data set that has intervals, how do we find the mean here? Because remember, up until now, we've always had add up all the x's divided by n, or add up all the, if you have frequencies. But these are all solid numbers. What happens when you have an interval? No, that would find the relative frequency. The mode is not subject to the relative frequency. The mode is relative to the data itself. So the relative frequency, I see how you're saying that, but it wouldn't give us the same answer because we need to refer only to these data sets. So the only way we can do that is if we want to find the mean, is we have to find what's called the midpoint. Midpoint of the interval. So how do you find the midpoint of an interval? Take the lower bound plus the upper bound and divide by 2. Basically, what you're doing is I want to find the average of this interval. So in our example, in the first set, what's the lower bound? 1, that's the lower bound, plus the upper bound is 5. 1 plus 5 is 6 over 2. So the midpoint of that first class is 3. Okay, the beautiful thing is we don't have to do any more calculations. You notice how the lower bounds from 1 to 6, what do I do to get from 1 to 6? Add 5, yeah. And then from 6 to 11, add 5. Yeah. How about the upper bound? From 5 to 10, I add 5. And so going from the midpoints will be the same thing. So from the midpoint of the first set to the midpoint of the second set is how far? 5 units. So 3 plus 5 is 8 plus 5 is 13 plus 5 is 18. So far, so good? Because now we have a solid number. This number 3 represents this class as a one number, as a single number. So our mean is going to be the summation of our midpoints times the frequencies over n. That's the new formula for it. So we have to do the midpoint times the frequency. So 1 times 3 is 3, 2 times 8 is 16, 4 times 3 is 52, 3 times 18 is 54. Add up all those. You get 125. Divided by how many? How do I find n? Everything what? No. How do I find n? Add up the frequencies. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So n is 10. So the average is 12.5.
You apply for the X. Oh,
The frequency times xm. Yeah, and that's another thing. We have to learn how to build these charts. So you're given a formula, you have to build the formula. Because trust me, it'll become much longer when we do variance and deviations. So it'll be a longer formula. So that's the mean. What's the mode? Right, it's a modal class. Very good. It's from 11 to 15. That's the modal class. Because it's got the highest frequency. And for the median, we do the same thing we did last time. We have to get a cumulative frequency. So in the first cumulative frequency, what number goes there? Oh, I'm sorry. Thank you. It looks good here under my screen. So what number goes here under the first CF? What's that? Look at the frequencies. 1. What goes under the second one? No. It's cumulative frequency. 3. Because we start off with this one, we add that, we get 3. What's the next one? 7. 3 plus 4 is 7. And the last one? 10. And we do the same thing. So to find the mode, take n divided by 2. So 10 divided by 2 is 5. It's an integer, so we go to the 5th location and the 6th location. So where is the 5th location? No. This one has the first one. The next one, this one has one of these. Then the next 3, this is 1, 2, 3, 4 going here. 5, 6 goes here. So 5 and 6 go in this data set, which is represented by 13. So we go 13 plus 13 divided by 2 is 13. So that's how we do the mode of median of a modal class of intervals.
Yeah, what number is that?
Continue the logic. The equal sign,
That's, I can't tell.
it's a 2. Okay. All right. That's the end of that section 1. Now the rest of the chapter will be graphs, different representations of graphs, whether it's a frequency distribution or a modal distribution or whatever. Okay, everybody, have a great day.